Hi everyone. So this week we're going to talk a little bit more about metal cutting processes, okay? So we talked about welding, but now you need to figure out how to cut those various pieces of steel or aluminum or any other metal for that matter to be able to join them together. And so maybe you've got a piece of sheet metal like this right here, okay? Now that plasma cutter that we look at today will be great for this piece of sheet metal, okay? Maybe you've got a piece of massive solid rod that sits like this, and now you've got to cut through this, okay? Or that looks very different than this piece of just small 1-inch square tubing, okay? So it depends what you're trying to achieve on a farm or ranch. Maybe you're trying to build something new. Maybe you are trying to cut a hole in some pipe, or maybe you're just saddling something to install some pipe fence. And so first I wanted to show you a few cold processes that are out there. Once we get over those cold processes, there's not a whole lot in the how-to. I just want to show you what's out there on the market. We'll move into our main discussion today, which will be surrounding that oxyacetylene torch and that plasma cutter. And so I've got a few things here. This is a large bandsaw, and so if you looked at this, you can see large teeth on this. This is hydraulically raised and lowered, and so this will go down with the weight of it on top of our steel. We can simply kick this on, kick it off, and it will stop once it goes down on top of our steel. They make these large bandsaws that are dry like this or have hydraulic fluid with them to help cool that steel as it goes down, and some cutting fluid. A couple other things I threw out on the table that are common. By no means is this all inclusive of various cold cutting solutions that are out there. This one is very common on the market. This would just be an abrasive chop saw, okay? And so this abrasive blade wears down over time. You can buy new ones, attach them. This is great for cutting that square tubing, anything like that on a common project. This is going to be a little thick for something like this chop saw right here. This would be much better cut on that large bandsaw, okay? You can also get small bandsaws, okay? This would be a small battery-powered bandsaw. I've got a large one of these that plugs into the wall. This is simply a pull the trigger, and we can go through. We could easily cut that 1 square tubing with this, or we could cut anything else that was. This is a 2-inch throat in here. The larger one goes nearly up to 4 inches, and so we could take this over to our, again, square tubing. Simply pull the trigger. And just like that, cut straight through that steel with this, again, handheld bandsaw. And so great things to have around. They make circular saws that have diamond carbide blades on them, and those circular saws will cut through steel. Endless options. But again, those are cold. Now today I really want to focus on two main setups that are hot processes. One being that oxidative process with the oxyacetylene torch. The second being that thermal process with our plasma cutter. And so let's start diving into those. We'll go over kind of the startup safety features surrounding oxyacetylene and then talk about technique. Okay, here we go. Okay everyone, so a couple quick things in regards to starting up the procedure for oxyacetylene before we get to the technique. And that's just to keep in mind with your tanks, okay? Our larger tank here is our oxygen, our smaller is our acetylene. This is our fuel source. Again, this could be a number of different fuel sources. This could be a propane, it could be a MAP gas, but we're using acetylene, okay? And so oxygen here, the thing to remember when you turn this on is this is a double-seated valve. This valve needs to be turned on all the way. And so turn it on slowly at first. Once you get the pressure you can hear build, then all of a sudden you can turn it on a little bit quicker, and again, all the way. Acetylene, because it is something that we worry about, it's dangerous and it becomes unstable above 15 psi, we only turn this on about 1/2 to 3/4 of a turn, okay? Now, on our dials, originally there's no pressure on our regulators. I've already adjusted these, and so from these, you can see this right dial is our tank pressure. This one is our line pressure. This is our working pressure. And so we've got plenty of oxygen in our tank, and then right now we've got this set at about 30 psi's for our line. On our acetylene here, we've got good tank pressure, plenty of acetylene in the tank, and then our line pressure is about 6 or so psi. And so we've got those adjusted for the thickness of steel that we are going to cut. Notice our tanks are chained in the upright position. This is always something that is important. Make sure that these don't fall over. We talked about those caps, making sure that if you do not have a regulator attached, that you have a cap on this, okay? The last thing you would ever want is for one of these tanks to fall over and this valve to then snap off. This becomes then a projectile and a little bit of a rocket, okay? And so we've got caps around if we were to take those regulators off. And so all is set up, our tanks are on, our regulators are adjusted. I've actually got a reel that's be able to adjust this, and I'll show you that ever so briefly. And so if you guys can see this reel, this is 50 foot of hose, oxyacetylene, that you can then pull out, and it's a slow retract, which makes things pretty nice, and that's hooked up to those tanks. We talked about our two hoses here, our red one being our acetylene. This is left hand threads. If you came down, you could see the connection and the notch on things, means left hand. And then our green would be our oxygen, that comes down, right hand threads, okay? I've got a torch body here. These are just a quick connect on here because of the way I've got this set up. Most of the time that is a permanent connection, okay? And so let's go over to our welding cutting table now and talk a little bit about PPE required, and then dive into that technique and cutting process. So we've got our oxyacetylene torch here. This is a pretty big torch. This is a Victor torch. Again, I've got quick connects on our acetylene and on our oxygen. I haven't done anything yet. And so to go ahead and start this off, I'm going to go ahead and open up this oxygen line all the way, because the cutting torch, this oxygen is the one I'm actually going to adjust. I'm going to purge our oxygen line. So turn it on, about 5 seconds. Close it off, make sure just oxygen is in that line. Do the same with our acetylene and our fuel. Turn this on, I can hear it, 5 seconds, turn it back off. Okay, we're good to go. So those lines are purged to ensure that only oxygen is in the oxygen line, only acetylene is in the acetylene line. We don't have to worry about any flashback or combustion occurring inside that chamber that we wouldn't want moving back towards our tanks. Again, most of your torches these days have flashback arresters in them, but you can buy some aftermarket if that's something that you don't have. And so with this torch, again, we could have different attachments on here. We're only concerned with cutting today with our metal cutting processes. One thing I'm going to do is I'm going to inspect the orifices on the top here. And so we've got various holes around the outside. Those would be our preheat holes. This one has 6 preheat holes. And then in the dead center, this is going to be where our pure stream of oxygen comes out when I depress this lever right here, okay? And so all those holes are perfectly clean, okay? And so now let's talk just briefly about PPE before we go ahead and light our torch. I've got leather gloves on. For me, I find leather gloves are just fine for doing oxyacetylene torch and plasma cutter that you'll see here shortly. If you have too much heat and you feel it's too hot, depending on what you're doing, then wear welding gloves. If I'm cutting pipe and I'm doing a lot of it constantly, sometimes this is not enough, okay? For the little shortcut that we're doing today, this happens to be just fine to have these leather gloves on, but you do need to have some type of hand protection, okay? The next thing that we need is a shade 5 glasses, okay? They make these a lot more stylish now than they ever used to. Used to have these big, massive goggles that would flip up. Maybe you want those, but these look much like sunglasses, but they're quite different. They're actually a shade 5, so don't use just a regular set of sunglasses. They are not strong enough, okay? If you look through these outside, it looks very green, okay? But they're a pretty dark shade. So PPE required. We've got our glasses on. We've got our gloves, and then I'm wearing a closed-toed shoe, cotton jeans, nothing that's a synthetic or flammable. Looking around the area, there's no other fuel sources, nothing that's going to catch fire either, okay? Now when it comes down to lighting our oxyacetylene torch, we're gonna use a striker, flint striker, just like this, okay? And so you can see, move this, you can see the sparks that come off. We don't wanna use an open source flame to ignite something like this, okay? And so to be able to light our torch, pretty simple, okay? And so we've got our valves closed off right now. We're going to open our acetylene about 1/8 to 1/4 of a turn, and then open it just a hair more. So this is a very sooty flame that you'll see right here. I'm gonna take that flame until that soot goes away, and it becomes a very bushy flame that you would see right now, okay? Once I have that bushy flame, I'm going to go ahead and add oxygen, okay? I add our oxygen. This right now is carburizing flame, okay? And so you can see this long feather as it sits out inside the flame. I need to get this down to a neutral flame. And so I'm gonna adjust that until we get right just back to that inner cone, and I know I've got a good neutral flame, okay? Now, things to remember when it comes down to cutting processes: one, make sure your hose is out of the way. You don't ever want to get your hose near the actual open flame and all of a sudden we have gases that are exposed. Now, to to be able to cut something like this, remember, compared to welding, we set our angle of work and our angle of travel are both 90 degrees, okay? And so we're gonna do just that. We'll come over here. Now, we're gonna start on the edge momentarily. And so if I start on the edge here, I'm just gonna preheat until I see all of a sudden this becomes a little bit of a molten puddle, which I've got right now. I depress my oxygen, cutting lever. And just like that, we've cut through, okay? And so, easy thing to be able to do. Again, we'll do that one more time. Okay, everyone, so I just realized you really couldn't see that steel that was cut in half, the small ticket on the last piece laying flat on the table. So I pulled a thicker piece of steel out just so you guys can see those angles and see it as it's cut. Again, remembering that we are 90 degrees to our work, so that means this angle, and then we're 90 degrees angle of travel, so not tilted one way or the other, okay? And so just to show you that cut one more time, we're coming over to our steel. Again, we're just gonna do a little bit of a preheat on the edge here until we see that molten puddle. Once we see that molten puddle, we're going to go ahead and depress our trigger, our cutting lever. You can see just like that, we've cut our piece of steel, okay? Again, I'm gonna turn off our oxygen first, and then our acetylene, and we're good to go. That process is done. And so you can see we've got a pretty clean cut right along that thick piece of steel. Again, this is over 1/4 inch steel, okay? And it cuts through that just like butter, okay? And so I think with that, that's the simplification of oxyacetylene. Let's roll into plasma. Okay, everyone, so you've got a little bit of a crash course in oxyacetylene. Again, that is an oxidative process, okay? And so that pure stream of oxygen cutting through that steel, it has to be something that can oxidize, i.e. rust, okay? And so really it only works on our mild steel, okay? If you want to cut aluminum, okay, you want to cut something like copper or any other material, you're going to have to go to plasma. Also, on that thinner material, that sheet metal, plasma also works much better, okay? But it also has the capability to go much, much thicker. And so this is a really small inverter-based plasma cutter, really cool. This is a Miller Spectrum 325 X-treme that we've got here. The cool thing about this, it runs off 120 volt power, or it'll run off of that 230, 240 volt power, okay? And so we've got this plugged into the wall, okay? And so we can go ahead and kick that on momentarily. You're gonna see the lights kick on here in the front. Now, it does need compressed air, okay? And so I've got an inline air filter, and the reason for this and what this inline air filter is going to do is filter out any water, okay? We do not want water or condensation from our airline making its way into this machine, okay? And so I've got that connected. We got our air compressor on, and next we'll go ahead and kick our machine on. Lights power up, tells us we've got power, we've got adequate pressure, our cup is good, our temp is good, all is perfect. And so from here we can adjust our amperage based on the thickness of the steel that we are cutting, okay? This white range is simply our range for 120 volt. This orange range is simply our range for 240 volt. And so we're only cutting 1/8 inch steel. This can cut up to 3/8 of an inch steel. And based on the size of plasma cutter you have, it can obviously cut 1 inch, 2 inch, 3 inch, up to 6 inch steel based on the plasma cutter that you have. The cool thing about some of these, General Dynamics or Thermodynamics is one of those companies out there that has a plasma cutter that has an air compressor built in. And so that's a really cool thing. You no longer need to have a compressor that you lug around with you and is able to keep up. It's an onboard compressor, and so that's a pretty cool thought. Now, once this has air compressor hooked up to the back, it's got power. The only other two components would be our torch. This would be that plasma torch as you see it. We've already got a brand new tip and electrode on here, and it's just a safety switch and trigger. Same angle of work, same angle of travel as the oxyacetylene torch that you just saw. Super easy to use. Now, because it is conducting electricity, we do have a ground clamp. And so we're going to use this welding table right here and just simply connect this ground clamp to our welding table. And so let's go ahead and get this machine off the table now that you've seen how everything hooks up to it, and let's show you how that plasma cutter actually works. Okay, so I've got our machine on the ground. I just want to quickly show you the components and how this plasma cutter works. Again, it's super simple. I got a piece of 1/8" steel out. I also got a piece of 1/8" aluminum, okay? Just to show you something that oxyacetylene torch cannot cut, this plasma will cut like a dream, okay? And so I'll show you from a distance kind of how this is set up, angles, and then we'll give you one more kind of close-up cut with this material as well. Same PPE as oxyacetylene. Again, less heat with this, and so our leather gloves are perfectly fine. We've got our shade 5 glasses that we're going to put on. And then from here, our torch, the key here to remember, again, 90 degrees to our work, and that's looking at the tip here, and so not one way or the other. And then angle of travel, also 90 degrees. Now, the key of this plasma is generally if you have a machine that's over 40 amps, you've got to maintain a standoff, okay? And so that might be a 1/16 to 1/8" standoff. If you've got a machine under 40 amps, you can actually take this tip right here and I can place it onto the steel and drag it along, okay? They do make drag shields for those machines that are over 40 amps to make it a little bit easier on you. And so, easy as, we don't need any preheat now. And so as soon as I pull the trigger, let's come over here, let's get all of our angles set. I pull the trigger, you see right away we're cutting steel. This is now in 2 pieces, okay? Now, there's less heat with this. The fact that I can pick that up and move it around, it is still warm yet, but it's not nearly as hot. So, you saw the cut from far away. Let's show you that up close now. Air compressor kicked on before, so I lost you anyways. But I've got our piece of steel here, and then I got our piece of 1/8" aluminum, okay? Things to remember, 90 degrees angle of work, 90-degree angle of travel, no preheat required. As soon as I pull that trigger, let's go ahead and watch. We'll cut right through this steel like butter. Just like that, it goes away. Let's show you what that looks like on a piece of aluminum. We got a little bit of a scratch there. There it goes. And so, again, super easy. A little bit of post flow. That'll go off here in a second. That post flow is just making it so that air is already flowing should you pick your cut back up. And so you can see we cut through that aluminum, we cut through that steel. Anything that conducts electricity becomes super easy. So you got to see that close up now. We've been over oxyacetylene, we've been over the plasma cutter, we've been over some cold processes. You have lots of ways that you can now go out and cut steel and then join it together with those welding processes we discussed, both stick welding and MIG welding. And so hopefully today you're a bit more informed. Great to have a plasma cutter on any farm and ranch. That oxyacetylene torch is an absolute necessity, and those cold processes are something you're likely to have around. And so with that, thanks again, and talk to you soon, y'all.